I will speak with you about procedural modeling. Um, of course, Danielle and some colleagues know very well what is it, but I will speak for other people too. What can we do with this thing? So my topic is using parametric modeling in the visualization of cultural heritage. Normally, when we are scanning, when we are modeling, we have some material. We can make measurements, we can scan, or we can use old drawings and survey materials. For example, here is our expedition in Kuwait. It was expedition of Georgian National Museum. We worked on palaces of Amir of Kuwait. Ghazal palaces, they were heavily damaged in the last 100 years. We did scanning, we did, from this scanning, we did data visualization, and of course, the corpus of drawings, architectural drawings, elevation sections, plans, etc. But also was the digital model, a constructive model, and then on the basis of all this knowledge, and of course of a lot of another things, for example, old photos, etc., was created a very exact model, 3D model of the building, how it looked like in old time. But it is, let's say, easy when you anyway have something you can measure. You can go there and measure with laser. You can scan it. So you have the important measurements, even by very destroyed buildings. But what to do when you need to visualize something what doesn't more exist? For example, there are some situations when you need to do it. For example, you are creating a background for your K object. Your K object, yes, you have drawings, but the urban structure was changed. So you should put old buildings, and you don't have exact material about these buildings, or you don't have time to model all of them, and you don't have resources. What can you do? And sometimes this parametric modeling can help you. I will show you our next. So here you have different types of housing, different types of architecture. You have here a village in mountainous Georgia. We have here Paris, we have Yemen, and we have Manhattan, old Manhattan, Art Deco style Manhattan. So, and you see they are very different, but inside of one time and one location, you have some architectural style and some architectural rules. So you can create, let's say, a theoretical model of building of such type, and then you can use it as you can multiplicate it. But by multiplication, you don't have the same objects, but you use some knowledge about how it would look like when it has, in the case of Manhattan, only 10 stores, 20 or 30. It's not the same. You cannot scale it. You cannot scale it. You should change the shape. Okay. Creating of abstract model, parametrization, randomization, and placing. So parametric modeling. You have some parameter. For example, you have the length of the facade. And when you change this parameter, the shape should be changed. But it is not just scaling, because when you are just scaling the building, you receive the nonsense. By scaling, you should change the initial building to some another. And here is the question how we can do it, how we can, for example, calculate the number of windows depending on the length of the facade. But I repeat, it will be actually for some given type of, or period of buildings, type of buildings. Of course, you are always inside one type at one time. So here are some equations how you can, by given parameters of windows. Yes, okay, we know that, for example, when we are doing European architecture of 800s, you have from 120 to 160 centimeter wide window. So you can write the equations for calculating the number of windows for this length of the facade. So it's in, but you don't need more to model it explicitly. You just give the length and the program will place it. So, okay, here are some theoretical questions. I don't want to be very slow here. Okay, levels of randomization. Another question is randomization, because we will not do the same buildings. We should change something. Or by old buildings, it's very important to age some shapes. It's very important to make them look like more ancient, more damaged. And here we have the levels of objects. We can randomize elements. We can make unregular stones. Yes, but there is also the great variety of old stones. But we are, I repeat it again, we are inside of one type of building. Yes. So we can randomize elements, but it's not enough. We have walls. So we should randomize elements, placing and sizes. So we create not only single elements, we create masonry, we create structures, we create walls. The third level of abstraction, randomize buildings parts. What we have seen here on easy example, yes? So how many windows will have this building? And the last and highest level of abstraction is randomized building placings. So you can give in idea, you can give the plan of the town and or part, of course, of it or some street, and the program will place buildings with various dimensions automatically on it. Okay, here is some mathematics. We don't need it. Aging objects. Now I'm going a little bit deeper in this question. How can we age, for example, stones? With help of very simple mathematics, vector mathematics, we can, for example, change a triangular shape, its idea, only idea, into the triangular shape with broken edges. So look here, the outgoing element is the quadr, but we can chamfer corner of this quadr, and how much we will chamfer it, I have it x, we can randomize it, or we can control it, make it more or less. But chamfered corners is not enough. We should then chamfer edges. Okay, this shape is more rounded, looking for some archaeological sites, more natural, but it's rectangular, but it's not in all cases. So maybe this idea to modify this simple box to chamfered corners and then this one to this one, I can put some randomization. Look here, I take this initial block, I move in randomized direction and in randomized distances the corner points, and then I apply absolutely the same transformation, and I can modify not only topology but also geometry of the object. Here is example, a quadra, how we changed the corners and then how we applied the topological modification. And then by use of some bump textures or some other methods of computer graphic, I can receive a more or less acceptable structure. And then I can apply it. For example, it was one excavation place not far from Tbilisi, and I should create in very few time some idea of the masonry, and it was two layers. The inner layer was from very raw stones. They were not worked well, but the outside was covered with flat stones which were better worked. And here, if you can imagine, I use the same model but with different parameters. I use the same model for these rosa stones, rounded stones, and for these gray stones, but the difference is only in some mathematical parameters. Here we can see, for example, two upper layers are here initially are quadras. Now I start video and you will see how it will change to more and more rounded boxes or stones, you see? So, and it is just an example how parametric modeling can help you to create or to create some unregular shapes. So in every parametric model, you have some constant values. You cannot parametrize all things. Yes, you always say that I will change this and this, but this and this should be more constant. And I will randomize this and this. And the same here. For example, I will change the length of the facade. And when I change it, it's too slow. I will do it. It's still not enough place for a second window on each level. But when it grows more, the system, the program will calculate from itself. Okay, now it is time. Now it is time to put one window more. Now, okay, second window. We continue, and here is enough place between windows to put some additional elements. Yes, and here we have third windows and so on. Okay, so we used it in one project when we needed some background houses, because we have modeled in our museum the central place of Tbilisi, how it looked like 150 and 100 years ago, because only 3 buildings from this square remained to our days. Okay, we have modeled 14 buildings exactly from drawings from measuring, but there was a lot of buildings, background buildings, and we had absolutely no material about them. There were only a few very bad quality photos. And what could we do in background? or sometimes we had material, but it is too far and too long to make a model. So we decided, we created 4 types of this, not vernacular, but easy build, let's call it background buildings. So 4 different models, but each of these models can be modified by the length as I have shown to you. So it is enough to give only the length of the elevation, and it will recalculate the elements. Here, for example, it is the same model, but with different parameters. This is the early stage of modeling of that place. And here, these gray houses are these automatically created objects. Okay, here are individual buildings. Okay, it is not but even in these individual buildings, apropos, this building was built from one Italian architect, Giovanni Scudieri, in 1850s. But here we use also parametrizing, for example, of opening of windows. Some windows are open, some are closed, some are a little bit open. It is also randomizing. Okay, but it is okay. Here is a link. We did also virtual tour. You can walk around here. Okay, but it is more urban. But what we will speak about our colleagues in Vani here, for example, we have, it's the gate structure. It is this mosaic temple. We could apply it in modeling of road. It is road with stones, with road stones, or by, for example, by modeling of walls. For example, Daniel had showed us these lamps, and we could model maybe the lighting of these lamps and how this lighting affects the walls. And in walls, we can use parametric modeling. Always, this parametric modeling is included in all modern software. When you are using 3D Max, or you can use reactors, or modern software has it. We don't need to write it mathematically from ourselves. But the idea of it maybe will be useful also in our projects, and I'm very happy we can speak about it, and maybe we can apply it in our project. So I tried to be very short. Thank you.